Hello and welcome back. Today we will be understanding how to solve systems of equations in three variables using the Gaussian elimination method. Here we are given three equations with three unknown variables, namely x, y and z, and we are to find out their values. First of all, let's convert the systems of equations into an augmented matrix. This is how your augmented matrix should look like. Okay, now let's talk about the method itself, the Gaussian elimination method, and how is it supposed to help us find x, y, and z in this particular set of equations. Okay, so we are to create a diagonal in our augmented matrix. By diagonal, I mean the first value of row number 1, the second value of row number 2, and the third value of row number 3 should all equal to 1. The values below the diagonal should be all equal to 0, and the values above the diagonal could be anything. We don't know. We don't really care yet at the moment. What we do care about is the values in the diagonal being equal to 1 and the values below the diagonal being equal to 0. We achieve this diagonal by the help of row operations, which are multiplication, subtraction, addition and division between the rows. Okay, so now we are looking at our augmented matrix. We are to check first of all the first value of the first row and whether or not if it's equal to 1. Here, luckily, it is equal to 1. So our row number 1, we leave it untouched. We don't have to do any operations on that. Okay, now that's done. We are to check the first values of both row 2 and row 3 and whether they are equal to 0 or not. Here, our first value in row number 2 is 2, while the first value in row number 3 is 1. They're not equal to 0. So we are to perform row operations in order to make them equal to 0. How do we do that? Let's get into it. Let's perform two operations, one on row number 2 and one on row number 3, which make their first elements equal to be 0. Okay, let's do that. We could do row number 2 minus 2 into row number 1 and row number 3 minus row number 1. What would that give us? Okay, so the operation that is happening on row number 2 is row number 2 minus 2 into row number 1. Okay, got that? Let's do it here. 2 minus 1 into 2, which is 0. 5 minus 2 into 2, which is 1. Minus 1 minus 2 into minus 1, that is 1. Okay, here 3 minus 2 into 1, what is that? Yes, 1. Now let's go to row 3. What's the operation that is happening on row number 3? Row 3 minus row 1. Let's do that. What is 1 minus 1? 0. What is 3 minus 2? 1. What is 2 minus minus 1? That's right, 3. What is 6 minus 1? That's right, 5. Okay, so we have successfully transformed row number 2 and row number 3's first elements to 0, right? Getting the hang of it. So our next step is to check the second element in row number 2, if that is equal to 1 or not. Luckily for us, yes, it is equal to 1, which means that we don't have to do anything else on row number 2. Let's move to row number 3. Okay, now let's check the second element in row number 3 and see if that is equal to be 0. Is that the case here? No. Our second element in row number 3 is 1 and we have to make it 0. Right, so how can we do that? Okay, so let's do a row operation for row number 3. What we could do is row number 3 minus row number 2. Why did I not use row number 1 for this calculation? This is because if I used row number 1, then the first element in row number 3 would have changed into something else and it would not have remained 0. I used row number 2 to do this calculation because the first element in row number 2 is 0, which means our first element in row number 3 won't be affected. Only the second and the third elements will be affected. That's what we need. Okay, so let's see the result. 0 minus 0, 0. 1 minus 1, 0. 3 minus 1, 2, right? 5 minus 1, 4. After this operation has been done successfully, we are to check row number 3's third element, and we are to check whether if it's 1 or not. Here, a third element in row number 3 is 2. That means our diagonal is still incomplete. Now, let's do a row operation on row number 3 once again. So, what could that be? We could divide row number 3 by 2. Now, let's check if our diagonal is complete. So, 1, 1, and 1. So yes, our diagonal is complete. Now, our work is not done just yet. Let's check if the elements below our diagonal are all equal to 0. So, 0, 0, and 0. So yes, that is true. Okay, so let's just rewrite this in the form of an equation like we had in the beginning. Okay, the first row in our augmented matrix had the elements 1, 2, minus 1, and 1. So we could create an equation from that which translates to 1x plus 2y minus 1z is equals to 1. Let's do the same for row number 2. What is that? 0, 1, 1, and 1. So how could that be translated into an equation? That's right. 1y plus 1z is equals to 1. Now, let's do the same for row number 3. That's right. 1z is equals to 2. Okay, upon further inspection of these three equations, what do we understand? We observe that equation number 3 is 1z is equals to 2. What does that tell us? That's right, the z variable is equals to 2. Let's just write that down. Z is equals to 2. Lovely. Now, we want to find out y. How can we find out y? Simple. We substitute the value of z into equation number 2. 1y plus 1 into 2 is equals to be 1, which means that our y equals to be negative 1. Now, we have found out z and y. Let's find out x. How do we do that? That's right, we substitute the values of y and z into equation number 1 to find out the value of x. Let's do that. 1x plus 2 into minus 1 minus 1 into 2 equals to be 1, which gives us the value of x to be equal to 5. So that is the Gaussian elimination method, which can be used to find out the values of unknown variables in a set of equations. Thank you so much for watching, and see you in the next one.